refer this second question. So here the condition given is, if the crank OA rotates at 60 rpm in the clockwise direction, then calculate the velocity of the slider B and the angular velocity of the connecting rod AB. Okay, so this is the given slider crank mechanism. OA, this crank is at 40 degree and length is 300 mm. AB length is 800 mm and this is the slider B. Okay, so we have to find out if the crank OA it rotates in the clockwise direction, means like this, at 60 rpm. This is not the angular velocity, rpm is given. So first we have to find out the omega by using the formula 2 pi n divided by 60. So this is 2 pi, n is 60 and divided by 60. So this is 2 pi, so 3.14 into 2, so this is 6.28 radian per second. Okay, so we should use this formula omega 2 pi n by 60 if rpm is given. Okay, if directly omega is given, then we will take the omega as it is in the problem. Okay, so we got the answer as a 6.28 rad per second. Okay, now draw the given diagram as it is and locate the ICR. Okay, so this is the given system. Here crank OA, it rotates in the clockwise direction. Omega is a 6.28. This is the connecting rod AB and this is the slider B. Okay, so as this crank rotates in this direction, it means velocity of the point A, it is in the upward direction and it is perpendicular to the crank OA. Okay, so draw the perpendicular to this line OA, that is the velocity of the point A. So it is in the upward direction. So this is VA. Okay, so as this crank rotates in the clockwise direction, it means the slider, it will move on the right side. So draw the velocity vector of the point B on the right side. So this is VB. Okay, now draw the perpendicular to VA and the VB. So perpendicular to VA, it is along the crank OA, so it is the same line. So just extend this line like this. So this line is perpendicular to VA. Now draw the second line perpendicular to VB. Now this intersection point, this is the ICR point. So this is the point I. So I means it is the center of rotation for this connecting rod AB that has translation as well as rotation. Okay, so if you observe this crank crank AB, it will rotate in this direction. Okay, it means in the anti-clockwise direction. So this is the angular velocity omega AB for the connecting rod AB. Okay, so for a particular moment, this connecting rod, it is rotating about this ICR point. Okay, now in the triangle ABI, which is the triangle of ICR, we have to find out two distance. This is the distance AI and second distance is distance BI. Okay, so to find out these two distance, we must know this angle and this angle. Okay, so now refer the first triangle OAB. In this triangle, one angle is already given, so it is 40 degree. Okay, distance AO is given, it is 300 mm, so this is 0.3 meter. Distance AB is 800, so this is 0.8 meter. Okay, now by using this 0.3, 0.8 meter and this angle 40 degree, we can find out the remaining angle. So this angle. Okay, so let us assume this angle as a phi. Okay, now consider this triangle OAB and use the sine rule. So in the triangle, This point is O, this point is A, and this point is B. Okay, this angle is given 40 degree. This is 0.3 meter, this is 0.8 meter, this is the unknown angle, so let us assume this as of phi. Okay, so now use the sine rule in this triangle. So known side is 0.8, sine of opposite angle, so it is sine 40 equal to, this is 0.3, sine of opposite angle, so this is sine phi. Okay, now from this we can find out the sine phi. So sine phi is equal to, just do the cross multiplication, 0.3 into sine 40 divided by 0.8. Okay, and then we can find out phi. This is equal to 13.95 degree. Just take the sine inverse. Okay, now we got the angle phi. Now we can find out this angle. Okay, this is 13, this is 40, so this is 180 minus. So this angle A, this is equal to 180 minus 40 minus 13.95. Okay, so this is equal to, it is 126.05 degree. Okay, now see this triangle, the triangle of ICR. Okay, this angle, that is angle B, it is 90 minus phi, so this is 76.05. This angle, this is the single line. Okay, so this total angle is 180 degree, so 180 minus this angle, so it is 126.05 degree. So this angle will be 180 minus 126, so this is 53.95 degree. And then this remaining angle, this is 180 minus 76 minus 53.95, so this is 50 degree. Okay, so now in this triangle we know all the angles, angle B, angle A and angle I, and we know one side which is 0.8. Now again by using the sine rule we can find out this BI and distance A. Okay, so now refer this triangle. This point is B, this point is A, and this point is I, which is the ICR point. Angle B, this is 76.05, this angle is 53.95, and this angle, this is exactly 50 degree. Okay, one side AB is known, which is 0.8 meter. Now to find out BI and AI, use the sine rule. So unknown is BI upon sine of opposite angle, so sine 53.95 equal to, known is 0.8 divided by sine of opposite angle, so sine 50 equal to, unknown is AI upon sine of opposite angle, so it is sine 76. Okay, now consider first two terms, do the cross multiplication and find out BI. So this is equal to 0.8 into sine 53.95 divided by sine 50. Okay, so from this we can find out the distance BI, that is equal to 0.844 So bi is 0.844 meter. Now consider the last two terms. So 0.8 into sine 76.05 divided by sine 50, and this is equal to distance ai. Okay, so from this ai is equal to, so this is 1.04 meter. Okay, so we got the answer for bi and distance ai. Okay, now we can use the basic formula v equal to r omega. Now consider this link OA, okay, and find out the VA value. So V equal to R into omega. Okay, for velocity A, first consider the point A. It is the part of OA, which is the crank. Crank has angular velocity 6.28. Okay, so VA is equal to R will be distance OA into omega is omega for the crank OA. So this is equal to OA, this is 0.3 meter into omega OA, it is 6.28. Okay, so from this we get the value for VA, that is equal to 1.89. Okay, so this is 1.89 meter per second. Okay, so this is the first answer for the velocity of A. Now consider again same velocity VA, this is equal to R into omega. Okay, but now consider this VA, it is a part of this connecting rod AB. Okay, so consider point A, it is the part of AB that has angular velocity omega AB. Okay, so right here omega as omega AB, and R will be distance of point A from the point I. Okay, so distance AI. So this is distance AI into omega AB. Okay, this is the second formula for VA. Now put the value of VA, which is 1.89. This is equal to distance AI, it is 1.04 into omega AB. Okay, so from this we will get omega AB, this is equal to 1.817 radian per second. Okay, so this is the angular velocity of the rod AB, which is the connecting rod. Okay, and last consider this slider motion that has a velocity VB and the center of rotation is a point I. Okay, so for this slider we can write VB, this is the velocity of the point B, R into omega. Now here omega is just omega AB because slider B, it is a part of this connecting rod only. Okay, so R will be distance of point B from the ICR, so distance BI into omega AB. Okay, so distance BI is 0.844 into omega AB, it is 1.817, and from this we get the value for VB, it is 1.53 and unit is meter per second. Okay, so from this triangle our first calculation is we have to find out some unknown distance. Okay, that is distance BI and distance AI. For that either we will use the sine rule or there is one more rule which is the cosine rule. Okay, and then next calculation is just V equal to R into omega. Okay, refer this next question on the slider crank mechanism. So here this collar or this slider, it is moving in the upward direction that has a velocity VB, it is 1.5 meter per second. Okay, so as the collar moves in the upward direction, this rod AB or rod BA, it will move like this. Okay, so the point A, it will make the contact with this inclined surface, and the velocity of point A, it is always parallel to this inclined surface. Okay, so this is the motion of the rod AB. So rod AB or rod A, it will slide on this inclined surface. Okay, so the velocity of the point A is always tangential to the inclined surface. The question is, we have to find out the velocity of the point A and velocity of the midpoint C. There is point C, it is exactly at this center. Okay, so 0.6 and 0.6 meter. Okay, now the first step is draw the given mechanism as it is and try to locate the ICR point for the rod AB. Okay, so here rod AB, it has general plane motion, means rotation as well as translation. Okay, so this is the given system. The velocity of the slider, it is already given, so draw the velocity vector in the upward direction. So this is VB and that is equal to 1.5 meter per second. Okay, so as the point B moves in the upward direction, point A, it will move along this plane in the upward direction. Okay, so velocity of point A is exactly along this plane. So draw this velocity vector exactly parallel to the plane. So this is the velocity of the point A. Okay, now this link, it is rotating like this. Okay, therefore it will have the center of rotation somewhere here. Okay, so to locate that, draw the perpendicular to velocity vector VA and draw the perpendicular to velocity vector VB. So this intersection point is nothing but the ICR point. Okay, now to find out the velocity of point A, we first find out distance BI and distance AI. Okay, for that one distance is given, so this is 1.2 meter distance AB. We should calculate this angle and this angle. Okay, so for that refer the given angles. One angle is already given, this is 50 degree, so this angle is 50. As this is 50, this total is 90 degree, so this angle will be 40 degree, 90 minus 50. Okay, this angle is 25 degree. Okay, and VA, it is along this plane. Okay, so velocity vector VA has angle 25 degree. Now just make one construction, just extend this line and from point A draw the perpendicular. So you can see this is 90 degree, this is 50 degree. So this total angle in this triangle ABM, okay, this is 90, this is 50, so total is a 40. From 40, this angle is 25, so this angle will be vector VA with the line AB, this is 15 degree. Okay, so 40 minus 25, so this angle is 15 degree. Okay, now here this line AI is perpendicular to this VA vector. Okay, so this total is a 90 degree. From the 90 subtract this 15 degree, so this internal angle, this is 75 degree. Okay, now this is 75, this is 40, so the remaining angle, this is 180 minus, so this is 65. Okay, 180 minus 75 minus 40, so remaining angle is 65 degree. Okay, now our aim is we have to find out distance BI and distance AI. Okay, so consider the triangle AIB. Okay, this is 1.2 meter, this angle is 65 degree, this angle is 40 degree, and this angle is 75 degree. Okay, now use the sine rule. So by using the sine rule, distance AI upon sine of opposite angle, so sine 40, this is equal to, known is 1.2 upon sine of opposite angle, so sine 65, equal to, now distance BI upon sine of opposite angle, so this is sine 75. Okay, now consider first two terms, do the cross multiplication and find out the distance AI. So the distance AI 0.851 meter, and consider the last two terms and do the cross multiplication, find out distance BI. So this is equal to 1.28 meter. Okay, so this is our first calculation to find out this unknown distance AI and BI. Okay, now we will use the formula V equal to R omega. Okay, so first consider the point B, it is rotating about the point I. Okay, so we can write V equal to R into omega. Now this velocity is already given, that is a VB. So right here VB, it is equal to, for a moment point B is rotating about point I. Okay, so radius will be distance BI. So distance BI into angular velocity. Now the point B, it is the part of this connecting rod AB, and this rod AB is rotating in this direction. Okay, so this rod has angular velocity in the anti-clockwise direction. That velocity is omega AB. Okay, so this rod has two motion, one is angular motion and second is the translation of B and translation of A. Okay, so right here omega AB. So this is the equation for VB. So VB is given, this is 1.5, this is equal to distance BI is a 1.28 into omega AB, and from this we get the angular velocity of the rod AB, which is omega AB is equal to 1.172 rad per second. Okay, and next from this angular velocity we can find out this VA. So velocity of A is equal to R into omega. Now here R means the radius from point I, so distance AI into omega. Now point A, it is the part of the same rod AB, so omega AB. So distance AI is 0.85, it is 1.172. So from this we get the value VA, this is equal to 1 meter per second. Okay, and the last is we have to find out one more velocity of the center point. So this is the point C. Okay, now to find out this velocity, first we should join the center C with the ICR point. Like this. Okay, now here as the rod is rotating in this direction, means velocity vector of C will point in the upward direction and it is perpendicular to this radius vector. Okay, so draw the perpendicular like this. So this is VC. Okay, now to find out VC, we can use VC is equal to radius into angular velocity. Now radius means distance CI into angular velocity will be velocity of the rod AB. Okay, so this is the formula for VC. Omega AB is known, we have to find out distance CI. Okay, so to find out this distance CI, we will use the cosine rule. Okay, so here distance CB, if you consider the triangle, if you consider this triangle BCI, then here angle B, this is 40 degree. Distance BC is exactly half, so this is 0.6 meter and this is 0.6 meter. Okay, distance BI we have already calculated, so distance BI is 1.28 meter. Okay, so the cosine rule is, if you know the value of two adjacent sides and if you know the angle between them, then we can find out the remaining side in the triangle. Okay, so now consider the triangle CBI. Okay, so in this triangle, unknown is distance CI square, this is equal to known is distance BI, so BI square plus BC square, second adjacent side, minus 2 BI into BC cos of angle between two adjacent sides. Okay, so cos of 40 degree. So this is equal to BI is 1.28 square plus 0.6 square minus 2 into 1.28 into 0.6 into cos of 40. Okay, so from this we can find out CI. Okay, solve this, take the square root, so CI is equal to, this is 0.906 meter. Okay, now once we get the value of CI, now this velocity vector, it is exactly perpendicular like this, so this is VC. Okay, so VC is equal to R into omega, and R is distance CI into omega of rod AB, so 0.906 into omega AB, this is 1.172. Okay, so from this we get the VC as 1.06 and unit is meter per second. Okay, so this is how we can use the cosine rule for the triangle. So this is the basic of the cosine rule. Just imagine we have one triangle ABC. Okay, distance BC is known, distance AB is known. Okay, angle between these two sides is given, that is a theta, and if you need the side AC, which is the unknown side, then we can write here AC square, that is the unknown side, this is equal to known is a BC, so BC square plus adjacent side is AB, so AB square minus 2 BC into AB into cos of angle between two known sides, so cos of theta. Okay, so this is the cosine rule. So by using this cosine rule we can find out the unknown side. Only requirement is two sides must be known and angle between these two sides must be given. Okay, we can find out the remaining unknown.